Good morning everyone. Today I am going to deliver a detailed lecture on the topic IS code, standards and specification in construction quality control. This topic is extremely important for civil and construction engineering students because it acts as a bridge between theoretical knowledge and real life construction practice. Many students study structural design, concrete technology and construction management but often fail to understand how these concepts are actually implemented on site. For example, whenever a building collapses, develops major cracks, or shows early deterioration, the first question asked by investigator is were proper codes and standards followed or not. So understanding this topic is essential not only for examination but also for your professional responsibility as a future engineer where safety of human lives depends on your decisions. First one is introduction in construction engineering. Quality cannot depend only on experience or personal judgment. Even an engineer with many years of experience cannot rely only on intuition. Every construction activity must follow written technical rules which are known as codes and standards. These rules are prepared after years of research, testing and field experience. Codes and standard ensures that is safety of human life, uniformity in construction practice, legal reliability, durability and long service life of structures. For example, if two engineers design the same residential building in two different cities, the building should still satisfy the same minimum safety requirements. This uniformity is possible only because of engineering codes and standards. Next one is what are codal provisions? Codal provisions are officially approved technical rules issued by recognized national or international authorities. They act as a technical guidebook for engineers. Codal provisions guide engineers at every stage of construction, that is, planning, structural design, material selection, construction methods, testing procedures, inspection and quality checks. For example, IS 456 specify limits for reinforcement spacing, concrete grade, and cover to reinforcement. If an engineer ignores these limits, problems such as cracking, corrosion, or even collapse may occur. Therefore, codal provisions are mandatory in engineering practice and are also legally enforceable. Next one is importance of codal provisions. Codal provisions play a vital role in preventing structural failures and accidents. They ensure that every structure meet a minimum acceptable safety level even under extremely conditions. For example, if a residential building is designed without following earthquake resistance provisions, it may collapse during seismic activity. Similarly, ignoring wind load codes in high-rise buildings can result in excessive sway or failure. Codal provisions also standardize engineering practice across regions and projects. They reduce guesswork and provide scientifically tested data, making construction safer, economical, and reliable. Next one is types of standard used in constructions. Construction engineering uses standards developed by both national and international organizations. Some major organizations includes that is BIS India, IRC India Roads, ACI USA Concrete, ASTM USA Testing, IS Code Indian Standard. For example, BIS standards are mandatory in Indian government projects, while ASTM standards are commonly used for laboratories testing in international projects. ACI codes are preferred for high-rise buildings and metro construction together. These standards ensure quality, safety, and global acceptance. Next one is Bureau of Indian Standards, that is BIS. The Bureau of Indian Standards or BIS is the national standard body of India. It is responsible for developing and publishing IS codes. BIS publishes standard related to concrete, steel, soil mechanics, masonry, construction materials, testing methods. For example, IS 456 governs concrete design, IS 800 governs steel structures. All government construction projects must strictly follow BIS standards. BIS ensures uniform construction quality across the country. Next one is important IS code in concrete. Concrete is the most widely used construction material in civil engineering because its strength, durability and versatility. Due to its extensive use, strict quality control is required and this is achieved through various IS codes. Several IS codes are dedicated to different aspects of concrete such as design mix, proportioning, production, placing, curing and testing. For example, IS 456 deals with structural design, IS 10262 deals with mixed design, while IS 516 and IS 1199 deals with testing of concrete. By following these IS codes, engineers ensure that concrete used at sites achieve the desired strength and durability. Failure to follow these codes can result in issues such as cracks, honeycombing, low strength, and early deterioration of structures. Next one is justification of IS 456. IS 456 is most important code related to plain and reinforced concrete structure in India. It provides detailed guidelines for structure design, reinforcement detailing, and durability requirements. The codes specify minimum grade of concrete, limits on reinforcement spacing, and requirement for cover to reinforcement. For example, inadequate cover can expose steel to moisture leading to corrosion. IS 456 also considers different exposure conditions such as mild, moderate, severe, and extremely environments. Structural in coastal or industrial areas require higher durability provisions. Thus, IS 456 ensure that concrete structure remains safe, durable, and serviceability throughout their design life. Next one is justification of IS 10262. IS 10262 provides a systematic and scientific approach to concrete mixed design. It helps engineers calculate the correct proportion of cement, water, fine aggregate, and coarse aggregate. For example, increasing water content may improve workability but reduce strength. IS 10262 helps maintain the correct water cement ratio to achieve both strength and workability. Proper mixed design also ensure economy as excess cement increases cost without improving performance. By following IS 10262, engineers can produce consistent and high quality control concrete at site. Next one is justification of IS 516 and 1199. IS 516 and IS 1199 are important code related to testing of concrete. IS 516 specifies procedure for testing hardened concrete, especially compressive strength using cube test. This test verify whether the concrete has achieved the design strength. IS 1199 deals with test of fresh concrete such as slump test, compaction factor test, and VB test. For example, low slump indicate stiff concrete, which may be difficult to place and compact. Together, these codes ensure that concrete quality is continuously monitored and controlled during construction. Next one is steel related IS codes. Steel reinforcement is used in concrete structure to resist tensile stresses. Therefore, the quality of steel plays a crucial role in structural safety. Steel related IS codes specify different grade of steel such as Fe415 and Fe500 along with their mechanical properties. They also define requirement for ductility, elongation and testing methods. For example, higher grade steel provides greater strength but lower ductility. Selecting the appropriate grade as per design is essential to avoid brittle failure. Thus, steel IS code ensure strength, safety and reliability of reinforced concrete structures. Next one is IRC codes, which is used in road construction. IRC stands for Indian Road Congress, which is responsible for developing standards related to road and bridge engineering in India. IRC code provide guidelines for planning, design, and construction and maintenance of road infrastructure. These codes consider factors such as traffic intensity, axle loads, soil condition, and climate. For example, highway carry heavy trucks require stronger pavement compared to rural roads. IRC code ensure uniformity in road construction practice and improve safety and serviceability of transportation systems. Therefore, IRC codes are mandatory for all highway and bridge projects in India. Next one is important IRC codes. Now, let us understand some important IRC codes that are widely used in road and bridge engineering. That is, IRC 37 is used for the design of flexible pavements. It considers factors such as traffic volume, axle load, repetition, subgrade strength, and climatic condition. For example, a highway carry heavy commercial vehicles requires a much stronger pavement compared to a village road. IRC 112 is used for the design of concrete bridges. It provides detailed guidelines for load combination, durability, and safety of bridge structures. Bridges designed without flowing IRC 112 may face premature cracking or structural distress. IRC 6 specify load standards including dead load, live load, and impact load on bridges. IRC 15 provides guidelines for concrete roads which are increasingly used due to their long service life. These IRC codes together ensure safe, durable, and efficient transportation infrastructure. Next one is ASTM standards. ASTM stands for the American Society for Testing and Materials. ASTM standards are internationally recognized and widely used for material testing and laboratory procedures. ASTM standards specify test method for cement, aggregate, steel, bitumen, and concrete. For example, ASTM test helps determine compressive strength, tensile strength, and material durability. In many international and multinational projects, ASTM standards are preferred because they ensure uniform testing procedures across countries. They help engineers compare results accurately and maintain consistency in quality control. Thus, ASTM standards play a crucial role in ensuring reliable and standardized testing practice. Next one is ACI codes. ACI stands for the American Concrete Institute. ACI code provide advanced and research-based guidelines for concrete design and construction. ACI standards over topics such as crack control, durability, and serviceability, and earthquake resistance design. For example, in high-rise building located in seismic zones, ACI provisions helps control cracking and improve ductility. ACI codes are commonly used in metro rail projects, tall buildings, and international construction works. They are known for their modern approach and continuous updates based on research. Thus, ACI codes contribute significantly to safe and advanced concrete construction practices. Next one is contract specification. Contract specification are written documents that forms an essential part of construction contracts. They clearly define what materials to use, how the work should be executed, and what quality standard must be maintained. For example, specification may define the grade of cement, the type of aggregate, curing, and workmanship standards. They also specify testing frequency and acceptable criteria. Specification act as a legal document between the client, contractor, and engineer. In case of disputes, specifications are used as a reference to resolve issue. Thus, contract specification play a vital role in maintaining quality and legal clarity. Next one is types of specification. Specification can be classified into different types based on their purpose. General specifications provide an overall descriptions of materials and workmanship. Detailed specifications describe each item of work in detail, including materials, methods, and measurements. Standard specifications are commonly used for routine construction works. Special specifications are prepared for unique or complex projects such as bridges, tunnel, or special foundation. For example, a standard specification may apply to normal concrete work while a special specification may be required for underwater concreting. These specifications ensure clarity, consistency, and quality control in construction projects. Next one is acceptance criteria defines the minimum requirement that must be satisfied before approving construction work. For example, concrete cube strength must be equal to or greater than the design strength. Steel reinforcement must meet the specified grade and mechanical properties. Workability of concrete must lie within the specified slump range. If acceptance criteria are not met, the work may be rejected, repaired, or reconstructed. This ensures that only quality work becomes part of the final structure. Thus, acceptance criteria act as a final quality checkpoint. Next one is role in quality control. Quality control in construction is achieved through a systematic combination of codes, specifications, and testing. Codes provide design guidelines, specification, control execution, and testing verifies performance. Together, they ensure measurable and verifiable quality. For example, regular testing of concrete cubes help detect strength issue early. This prevents costly repairs and ensure long-term safety. Quality control also ensure transparency in inspection and helps prevent disputes between stakeholders. Next one is conclusion. To conclude, engineering codes and standard form the foundation of safe and reliable construction. They ensure scientific design, standardized construction practice, and long-lasting structures. Ignoring codes may lead to poor quality, unsafe structure, and legal consequences. Therefore, every engineer has a professional and ethical responsibility to follow codes and standards strictly. Remember, no code means no quality, and no quality means no safety. Thank you, everyone.